Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic analysis of perfect frames. Here there are two methods, method of joints and method of sections. In previous video, the same numerical we solved by using method of joint. Okay, that video has given in the description box of this video. Okay, that video link I had given in the description box of this video. So for your reference, it's better you can see that video also. So in this video, we are going to solve this numerical by using method of joints. Okay. A cantilever truss of 3-meter span is loaded as shown in figure. Find the forces in the various members of the framed truss and tabulate the results. Here, a cantilever truss is given. The difference between cantilever and then the supported frames is the reaction force. Here you can see this is not supported at the ends. That means here there is no supported end. So there are no reactions. Then there is no reaction calculation also. So directly we can analyze by drawing the section line. In method of joints, we go to directly the corners like or each joints. In method of sections, directly we can go for the section line and analysis. That means reaction calculation is not needed here since there is no reaction force as we discussed in the subly supported frames. Okay. And one more thing, in method of section, among the three equilibrium principles, we are going to discuss the third one, that is algebraic sum of moment about any point equal to 0. Okay, here you can see method of joints, we used the first two principle, that is algebraic sum of vertical forces 0, algebraic sum of horizontal forces 0. Here we are going to discuss the third one, algebraic moment about any point equal to 0. And here we can see moment means we need the distances. Okay, actually we need this distance also. Actually here you can see this DA or AD, that is 3-meter span, and this ABD is an equilateral triangle. This 60 degree, this 60 degree, then this also 60 degree. If you draw a horizontal line, okay, sorry, vertical line, then this will split into two halves that will be equal. So this side 1.5 meter, this side 1.5 meters. Okay, because since it is an equilateral triangle. And one more thing, here, this point I'm going to consider for our reference E. Actually, guys, the BE is not a member. I just to draw a vertical line. Okay, so this distance BE is also needed. Okay, so it's better first to calculate the distance BE. Okay, so first of all, here you can see the BDE, that is an right triangle. Okay, or otherwise we can say BED, that is an right angle triangle. So here we can take right angle triangle, we can use the trigonometry principle like tan 60 degree, that is opposite side BE divided by the adjacent side DE. Here we need BE and DE that equal to 1.5, that equal to BE by 1.5. We need BE. So the vertical distance BE that equal to 1.5 tan 60 degree. So from this, if you substitute the value of tan 60, then we will get 2.6 meters. Okay. Here we know that the BE or this distance CD, that is also same distance. That is BE equal CB or CE, CD. Okay, that vertical value. BE CD, that equal to 2.6 meters. Okay. Now, I'm going to draw the section line. I'm going to draw the section line which intersects any two members, like here BA and AD. Okay, that is like this. I'm going to draw the section line. This is the section line 1, 1. This cut the members AB and AD. Here, I am going to consider, that means the section line can cut maximum 3 members. Left portions or right side portion we can consider. Here we are going to consider the right side portion of the section line. Okay. Right side portion of the section line 1, 1. Okay, right side portion of the section line 1, 1. That we are going to consider. Okay. And here, the concept is, in the considered portion, what are all the point loads are there that we have to consider. Point loads in the other side, that means not considered portion, that we don't want to consider. Here only 10 kilonewton is the point load, and that is in the considered portion. So there is no issue. Then in the considered portion, what are all the members are cut by the section line? Like here, AB and AE. These two are cut by the section line. So the forces in that particular members only we have to consider. So in this considered portion, there are 3 forces are there. 10 kilonewton, it's a point load. Then forces in the members AB and AE. Okay. Then take moment about other points to find out the values. Here, I am going to take moment about D. Okay. Algebraic sum of moment about the point D, and that should be equal to 0, since this truss or frame that should be in equilibrium. Okay. So here, the algebraic moment with respect to the point D equals 0. Here you know that, as I mentioned earlier, there are 3 considered forces are there. The 10 kilonewton and this force in the member AD, force in the member AB. Here, the force in the member AD, it may be a horizontal, it is a horizontal force. It may act towards the joint A or away from the joint A. Okay, but whatever, the line of action of the force AD that passes through the point A, E, and also D. So when you take moment about D, the line of action of the force TAD that passes through that particular point where we are going to calculate the moment. So the moment due to this force TAD, that will be eliminated. Okay. So for this case, we are not going to consider this TAD. So only these two forces, 10 kilonewton and T in tension force in AD. This I'm going to draw in sides for our reference. Okay. This is joint A, vertical downward force, 10 kilonewton is acting. There is an inclined force, the direction is unknown till now, TAB, then there is a horizontal force, that is TAD. Actually, here you can see that point D, that is here, where we are going to calculate the moment. From the point D, you can see the point A, that is 3 meter distance. Okay, this is at a distance 3 meters. This TAD, it's a horizontal force. As I mentioned earlier, it may act this direction or this direction. But whatever, that line passes through the point where we are going to calculate the moment. Okay, if it is like this or like this, whatever. So the moment made by the TAD, that we are going to eliminate. So only TAB, okay, that only we are going to consider. Okay, so here you can see this TAB and the 10 kilonewton. This two only we are going to calculate. So this 10 kilonewton multiplied by 3, that you can see that is in clockwise direction. 10 multiplied by 3. Okay, 10 multiplied by 3. This is in clockwise moment. So this clockwise moment should be counterbalanced by a counterclockwise moment. As I mentioned earlier, already this TAD, that we eliminated. Okay, so only TAB. But the TAB is at an angle 60 degree. We will resolve into two components. Here also there are two possibilities. If it acts like this, then we know that the TAB sine 60 will be this direction. TAB cos 60 will be this direction. But whatever the TAB cos 60 passes through the point D, then moment due to the horizontal component will be eliminated. Okay. So, but here you can see if this vertical component TAB sine 60, if it acts like this, then moment from D, that also will be clockwise. Okay, guys, this only for understanding purpose. I just explain both the possibility. Okay, so this will be in clockwise. So that cannot cancel this clockwise moment. Okay, if you want to balance the clockwise moment, you need a counterclockwise moment. So it will not act this direction. Okay, so it should act outwards from the point A. If it is outwards from the point A, it is an inclined force with an angle 60 degree. Guys, the TAD here already we eliminated. Okay, so this one, TAB sine 60 degree, this direction, the horizontal component, TAB cos 60 degree. Okay, but whatever, the TAB cos 60, that line also passes through the point D. So the moment due to the TAB cos 60, we are going to eliminate. So this upward force, TAB sine 60, this is at a distance 3 meters from the point D. So TAB sine 60 multiplied by 3 from the point D, that will be in counterclockwise. Okay, so this only I am going to consider. Okay, so TAB sine 60 multiplied with 3. Okay, so TAB sine 60 multiplied by 3. This is counterclockwise moment. Here you can see this 3 and 3 will cancel. So the TAB is 10 divided by sine 60 degree. From this we will get the value of TAB, that equal to 11.5 kilonewton. Here you can see from the point A, it is going outwards from the point A. So like this. So from point B also it will be outward. So here you can see it is compressive in nature. So that first force, what we found here, that is compression. Then I am going to take moment about another point. Okay, preferably from point B. When I take moment about B and that equal to 0. Okay, here you can see this one that I'm going to eliminate. That is here. You can see this is the inclined force TAB. And here you can see this is point A, this is TAB. I'm going to take moment about the point B. That will be here. Okay, this will be the point B. And this is the vertical distance BE. This is the vertical distance BE. Here you can see this TAB. Okay, here the direction we calculated already. It is passes through the point B. Okay, if it is outwards from point B and outwards from point A also, but the line passes through the point B. So when I take moment about B, the line of the force in the member TAB that passes through the B. So the moment due to the force TAB that I'm going to eliminate here. So only TAD and this 10 kilonewton. Here you can see this 10 kilonewton. This is the direction. Okay, so we can consider this is the direction of the force 10 kilonewton. So this 10 kilonewton is acting here, the line, and this distance. That means here you can see for the direction, the 10 kilonewton will be here. This distance, that will be same AE, that is 1.5. Okay, the 10 is passes through here also. So the perpendicular distance will be this 1.5. Okay, so that distance will be 1.5. And we know that this 10 kilonewton is this direction, clockwise. When you take moment about B, so 10 multiplied with 1.5, the distance, that will be clockwise in direction. That equal to, okay, this TAB already eliminated. The only the thing is the TAD. Here, there are two possibilities there. If this TAD, if it act like this, do you understand? Away from point A. Then from point B, this will be in, this also in clockwise. From the point B, this also in clockwise. So it will not act like this. It will be inwards to the joint A. That means like this. So when you take moment about B, we can take this one, TAD. Okay, the TAD multiplied with BE, that will be in counterclockwise. We are going to take moment about B, TAD multiplied with the distance BE, the perpendicular distance. Okay, TAD perpendicular distance BD. Do you understand? So TAD multiplied with the perpendicular distance BE. The BE we calculated already 2.6. So if you substitute and simplify, this is counterclockwise. We got the value of TAD. Okay, the value of TAD that equal to 5.75 kilonewton. Here you can see for the point A it is invert. So for point D also it is invert. So from this will be tensile in nature. Okay, that is tensile in nature. Okay. Now I am going to draw another section line. Okay, 2, 2, which intersects BC, BD, and also BA. As we discussed earlier, a section line can cut maximum 3 members. Okay, if it cuts more than 3 members, that will be tedious. To avoid the confusion, I just erase the section line 1, 1. Okay. So here I'm going to draw another section line which passes through BC, BD and BA like this. Okay. So this is the second section line. Section line 2, 2. Okay. And then as usual, we can consider two portions of the section line. Either here you can say the above and below the section line. Here I'm going to consider above the section line 2, 2. I'm going to consider upper side of section line 2, 2. Okay, that I'm going to consider here. I just draw the free body diagram here for our understanding. Here point B is there. From point B, as we discussed earlier, here these portions, the upper side of the section line 2, 2, that only we are going to consider. So first one, the point loads in the considered portion, that only we have to consider for the calculations of moments. Here this 10 kilonewton, okay, this is not in the considered portion. Do you understand? Here this is the upper portion, this 10 kilonewton is in the bottom side portion. You understand? It is not in the considered portion. So this 10 kilonewton we will not consider. Okay. So the point loads which are all outside the considered portion, that we don't want to calculate or consider in the moment calculation. Then the forces in the member which are all cut by the section line, that we have to consider, like BC cut by the section line, so that we have to consider. BD, that is also cut by the section line, that also we have to consider. BA, AB, that also we have to consider. But this BA or AB, that already we calculated. This BC and BD, this only we are going to calculate. Okay, so the free body diagram. So only three forces. Force in the members, BC, BD and AB. So from the point B, this side, force in the member BA or AB, that is acting. The horizontal force in the member TBC is acting. Then another one incline, that direction also unknown, TBD. Here this TBC, TBD, these two things we have to calculate. And then we know that if this is 60 degree, this also 60 degree, and this also 60 degree. If this is 60, this is 60. So this, with respect to this angle 60, this angle 60, these two inclinations or 60 degree with respect to the horizontal which passes through the point B. Okay. So then I am going to take moment about, and here for the free body diagram, I am going to take moment about D and C. Okay, so where are the points D? That will be in the extension of this one. Okay, here it will be D, and then the vertical line from here. Okay, this will be the vertical line from point D. Okay, that will be C. From this member is also calculate, that means acting. And the extension of TAB, here the point A will be there, and this is in the extension, that means this distance AD, that will be 3 meters. From the point B, if I draw another line BE, this side 1.5 meter, this side 1.5 meter. Guys, here whichever shown in the color yellow, that only the considered portion or considered forces. Okay, other things and all only for our reference to take the moments. First, I am going to take the moment about D and that equate to 0. When I take moment about D, here you can see there are three forces are there. When I take moment about the point D, here you can see this TBD. First of all, this TBD. It may act inwards to the point B or outwards to the point B. But whatever, the line passes through the point D from where you are going to calculate the moment. Okay, the line of action of the force BD that passes through the point D. Okay, so the moment made by the force TBD that we are not going to consider here. So the moment made by the other two forces TBC and TAB, that only we are going to consider. Do you understand? These two we are going to consider. This we are not going to consider when you take moment about D. Okay. So here, then among these two, this TAB, we can take this TAB passes through the point A also. And the direction also we know. That means from the point B, it is like this. So here, from the point A, that means this TAB, this direction, because you know, for point A, it is acting like this. But here, the considered portion, that is with respect to the point B, this force is outward from B. That means this direction, like that only you have to consider. This force we are not going to consider because that is not in the upper side of the section. Okay. So this force TAB, that is passes through the A, this direction. You understand? Like this, so like this. Here, the TAB sine 60, that will be vertically downward. TAB cos 60, that will be this direction, horizontal. But the TAB cos 60, we are not going to consider since that line passes through the point D. The horizontal force or horizontal component TAB cos 60 that passes through the point D, so that we are not going to consider. Okay, only this one, TAB sine 60, that only we are going to consider. And that vertical multiplied with the value 3. With respect to D, we know that that will be in clockwise direction. So TAB sine 60 degree multiplied with 3 meters from the point D, that is in clockwise direction. Okay, that equal to, here this is over. This is also we are not going to consider. TBC. When you take moment about D, this TBC, it may act towards left side or towards right side, whatever. Here you can see, if it acts towards right side from the point C, then with respect to the point D, this TBC multiplied with this distance CD, okay, TBC multiplied with CD, that will be in clockwise direction. Okay, that will be in clockwise. That cannot counterbalance this clockwise, because if you want to cancel a clockwise moment, you need a counterclockwise moment. So it will not act towards this direction. It will act towards this direction from the point B, and hence through this point C also. So from the point C, if it acts like this, with respect to D, TBC multiplied with this distance CD, TBC with respect to CD, that will act in counterclockwise direction. So that equal to TBC multiplied with CD. And we know the value of CD, that is also 2.6. This is in counterclockwise direction. CD, that is 2.6, which is equal to BE. Okay, because BE equals CD. Okay, here you can see BE equals CD. So from this, the value of TBC, that we can calculate 11.5 kilonewton. And here you can see this one. From the point B, it is acting outward. So from the point C also, it is acting outward. Okay. So here you can see it will be compressive in nature. Okay. That will be compressive in nature. Okay. So the only unknown BD we are going to calculate. For that, we are going to take moment about the point C. Okay. For our reference, I just leave this diagram. So here, I am going to take moment about C and equate to 0. So when I take moment about C, this force TBC that passes through the point C, so I am going to eliminate the moment made by TBC. Then the TAB and TBD. Okay, this TAB and TBD. Here, guys, listen. This TAB, we are going to resolve into two components. Okay, like if this is this direction, from the point B, I just to draw the diagram here. From the point B, this is TAB. And we know that this horizontal, that angle will be 60 degree. So the TAB sine 60 will be downward. Okay. And that will act here. Then this one, TAB cos 60. Actually, here you can see the point C, that is here. Okay, here the point C is there. Here, this direction, the point E will be there. Okay, or we can take CB. Okay, CB. So here, this TAB cos 60, that passes through the point C. TAB cos 60. The TAB cos 60, that will act this direction. That passes through the point C. Okay. So the moment made by that one, we are going to eliminate. Okay. You understand? That is the moment made by this TAB cos 60, that we are not going to eliminate. So this TAB sin 60, when you take moment about C, the perpendicular distance CB or BC. Okay, this CB or BC multiplied with TAB sin 60, that I'm going to mention here. When I take the moment about C and equate to 0, the TAB sin 60 multiplied with the value CB, which is equal to 1.5 meter. CB or the DE 1.5. And we know that here this one is the downward vertical component. And with respect to C, TAB multiplied this distance 1.5. That will be in clockwise direction. Okay, that will be in clockwise direction. This should be balanced by another counterclockwise, that is TBD. Here the TBD is unknown in direction also. As I mentioned earlier, there are two possibilities. If it acts this direction, the vertical component will be downward. Then with respect to C, again, you will get a clockwise moment that cannot balance this clockwise, because to balance a clockwise, we need counterclockwise. So the point, that means the force in the member BD, that will not act this direction. That means outward from the point B, but it should act inwards to the point B. Okay. Now I'm going to draw this here. If it is like this, Okay. So it will be like this. Do you understand? T, B, D. Then the vertical component that will be here. TBD sine 60. This one that will be the horizontal component. TBD cos 60. But here you can see that TBD cos 60 that also passes through the considered point C. Here we are taking moment about C. So the TBD cos 60, that line passes through the point C. So we won't consider moment made by TBD cos 60 also. So the TBD sine 60 multiplied with this distance CB. Okay. TBD sine 60 multiplied with the distance CB. That will be in counterclockwise direction. Okay. So TBD sine 60 multiplied with the same distance 1.5. This will be in counterclockwise direction. So now we can cancel this 1.5, 1.5, sine 60, sine 60. So the unknown force TBD that equal to TAB. The TAB already we calculated 11.5. So TBD also 11.5 kilonewton. And for the point B, it is invert. For point D also, it will be invert. Like this. Okay. So we can say that will be tensile in nature. That is tensile in nature. So all the required forces we calculated. So now we are going to do the force table. Finally, force table. Okay. That means we have to tabulate all the values. First one, serial number. Second one, the members. Third, magnitude. And its unit is kilonewton. Fourth one, the nature. First, the member, that is AB. The magnitude will be 11.5 kilonewton, and that is compressive in nature. That is compression. Second one, the member AD. The value is 5.75 kilonewton, and it is tensile in nature, because you know the AD that tend to pull the body, that will be tensile. Third one, BD, that is 11.5 kilonewton, and that is tension in nature. So here you can see the value of BD, that is tensile. Fourth one, the member BC, that is also 11.5 kilonewton, and here you can see the BC, that is compression in nature. Okay. So all the required values are found, then the values are tabulated. Okay. So I hope you all understand this numerical by using method of joints. Guys, the same numerical we discussed by using method of joints also. Now we discussed by using method of section. The same numerical we discussed by using method of joint also. That video link is given in this video's description box. Okay, for our reference, you can use that video also. Okay, so by using method of joint and method of section, both we calculated the forces in the member and we tabulated the results. I hope you all understand this video. For more videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay. Okay, guys. Thank you. Thanks for watching.